All right, I'd like to first of all thank all of you guys for coming. What I'll be doing today is I'm hopefully going to give you guys an informative and an illustrative look at water quality changes within the Tar-Pamlico River Estuary. As you guys know, the Tar-Pamlico River Estuary is part of a larger estuarine system, the Pamlico Estuary system, which is the second largest in the United States. What you see here is bathymetry and LiDAR data that I've obtained. The cooler colors represent deeper waters, going to red, which is shallow waters to shoreline, and light green is low elevations to the brown, which is higher elevations. You can see the difference between the light green and the brown. That's the Suffolk Scarp. And just so you guys can get a orientation of where things are, this is Congo River. You have Washington around here, Blunt's Bay. You can actually pick out PCS phosphate from the LiDAR data right here. And then two of my marsh sites, one is Huddy Gut, about right here. The other one is Porpoise Point, around here. Studying marshes, it's important because marshes have the ability to actually slow down incoming floodwaters. So all those people that have those expensive houses all along the shoreline, you kind of want marshes, so you know, in times of high floods, they'll slow down this water, and marshes can actually absorb water, so the relative or floods won't reach their maximum potential. Here is a land use, land cover map of the same area. You can see here the light pink are marshes, so you can see the extent of marshes out toward Pamlico Sound and along the shorelines here. So my project will be focusing mainly on sedimentation, erosion, inundation, and wave velocities within the Tar-Pamlico River Estuary, and looking at how those relate to each other and how marshes are able to accrete with current rates of sea level rise in this area between 1 and 4 millimeters per year. Vertically exaggerated this so you can kind of actually, we're going to actually fly through the center of a river here. So what I want to show you is these different water quality profiles. What I'll be measuring, or what the different parameters are temperature, salinity, and turbidity that change depending on season and depending on the type of conditions, especially like the drought that we had this summer. I'm going to start, the first set of data is from June 28th. This is, that's not June 28th. This is salinity data up until about just past PCS phosphate. You're looking at the cooler colors represent 0 parts per thousand salinity to the warmer colors here range about 10 to 15 parts per thousand. You can see that it's fairly a partially mixed estuary, meaning that there's moderate flow coming down to actually slightly stratify this water. And you can see as we got in September, this is now the salinity profile. Actually see it's become a more well-mixed estuary. It scales a little bit large. It goes from 0 to about 30, or actually 25 or so. So you can actually see the salinities have propagated a little bit upstream compared to the last set. And now you look at current conditions, or fairly current conditions, in March. You can see that this ranges from about 0 to 20 is this warm color. 0 again is 0. You can see that it's again a partially mixed estuary. And now we'll go back to and check out temperature, or yes, temperature for the same times. Okay, and so you can see in temperature here we have some slight stratification between the warmer waters on top and cooler waters on the bottom. And this is because it's obviously during the summer it's warming up, the water coming down is warm, it's warming in the estuary, and this is cold marine waters coming in. And then you can see non-drought conditions for temperature for that. So now we'll go into turbidity. This is turbidity for June 28th. Again, cool colors represent low turbidities. Turbidity is the amount of suspended sediment in the water column, or how cloudy, I guess, the water is. So you can see this ranges from about 0 to 10. The river really does not get that turbid, especially in times of drought. You can see some kind of maximum here. Some kind of maximum that might, but the difference between this is 0 and that's 10. So it's not much of a difference in suspended sediment concentration. Then you see current conditions. Which this ranges from 50 to 0 or 1, about out here. You can see this maximum here over by Chakawaniti due to the interface between freshwater and saltwater can actually make density currents and turbulence, which actually can resuspend sediments in the water column. And so that I've shown you the differences between a drought season and now coming back into winter and current conditions.